Hi everyone, welcome to Mrs. Shin's class. Okay, today let's go over how to analyze and compare the box and whiskers. Okay, so if you have a look at this, for box and whiskers, it's including the lowest value and the highest value, median. What is median? It's a middle value, right? So median is Q2 over here, representing the middle value. Lower quartile is Q1. Upper quartile is Q3. Okay, what it means, lower quartile and upper quartiles. If you have a look over here. Okay, so say that you have 100 values. 100 values. So the lowest value will be the minimum value over here. Okay, the biggest value will be the maximum value at the end, right? Put the values from smallest to biggest, ascending order. Find the median, which is the middle value, would go in here, right? And from this middle value and the lowest value, find another median from there. And here, this will be the lower quartile. And then again, right, from the median, the middle value to the highest value, find the median of it. There you go. This is the upper quartile. So basically, I can say from here to there, if I had 100 people, okay, 100 values, that's 25%. 25 values would lie in here. Again, 25 values would lie in here between lower quartile to median. Another 25 value median to upper quartile, and another 25 values from upper quartile to the maximum value. Okay, so it's quartile divided into 4. That's what the box and whiskers represent. Okay, so here you go. This is again box and whiskers divided into quartiles, 25% each. Right, so in order to find in the quartile range, you need to take away, you need to find the difference from upper quartile and the lower quartile. So Q3 minus Q1 will be into quartile range. Okay, and finding the range is you have to go greatest value, the highest value, minus the smallest one to find out the range. Right, so if there are two box and whiskers on the same scale, we need to compare them. What things do we need to look for? Okay, you have to talk about those 5 things. Number 5 interesting features is up to what type of box and whiskers you've got. So maybe sometimes you need to say number 5, but sometimes not. Okay, so let's have a look at the center. How do we compare the center? It's comparing the median. All right, so let's have a look at the box and whiskers example. So it's talking about the bag weight between male student and female student. Okay, how would you write this? How would you compare this? First of all, you need to tell us what you noticed about the median from that graph. Okay, so let's have a look. From our sample, I noticed that the median of what? Yeah, median of bag weight. We're talking about bag weight, right? Okay, bag weight of which group tends to be bigger or smaller than the other? Right, so yes, the median for female is this one, and median for male is this one. Yep, we're comparing. So obviously female median is bigger than male. All right, so bag weight of female tends to be bigger than the median of bag weight of male. Around, okay, now you need to talk about the difference. Okay, if you have a look and measure the difference, what would it be? It will be around 700 grams, isn't it? Okay, so that's how you start the sentence. So first of all, you need to tell me what you notice. Okay, then you have to explain why this maybe happened. Why did female bag weight is heavier than the medium male bag weight? Okay, just give me an example. One of the answers is that female tends to bring hairbrush, hair ties, deodorant for their PE class, right? Because they need to tie their hair and everything. And I noticed that, more female students tend to take dance class. Then they have to bring extra gears to school, right? And if they do music, okay, they need to bring instrument as well. So that will pull up the bag weight for the female. So that's just my example. Okay, so you can just think about it, give me your insight why this might have happened. Right, so ta-da! This is how we talk about the center, how we compare the center. Next one is shift. Okay, let's have a look. Whoop. Okay, what has happened? Yeah, so we know that, let's say the top one is A, the value of A are shifted further up the scale than the value of B. Okay, so we're looking at the middle 50%. What is the middle 50%? Okay, so say this is 25%, this is 25%, this is 25, this is 25, right? So that means this much is lower 25%. This much is lower 50%. Okay, then we can say this much is 25 plus 25, middle 50%. Yep, so the box represents the middle 50%, and from there to there is upper 50%, right? Okay, likewise from there all the way up till here, 25, 25, 25, lower 75% we can say, or from there to there, upper 75%. So we can say in percentile. Okay, so if we look again, right? So in here, middle 50% of group A is shifted further up the scale than B. Okay, so let's have a look. This is statistics test score for Year 10 student in TGS. This is boys and girls compared on the same scale, okay? Have a look at the middle 50%. The middle 50% of math test score is shifted further up than which one? Obviously girls. Middle 50% is shifted further up the scale than boys. This is the statement that you should make for shift. Okay, now let's add some values. What you need to say after this is you need to include some values. How? Like this. Okay, so lower quartile is over here, right? We're comparing those values. So lower quartile 39, which is for girls, minus 23, which is for boys, which the difference is 16, right? Now we need to compare median. Median. You see the middle line there? Yeah. So the median is 45 for girls and 27 for boys, and there you go. The difference is 18. And it's the same with upper quartile. Yeah, upper quartile for girls, upper quartile for boys, which is 22. So you have to talk about those values, okay? And what does this mean? Explain what it means. Yeah, obviously, what does it mean? Girls' math scores are better than boys, right? That's what I need to say. Okay, so if you want to show some insight, you need to explain why this might happen. Okay, just think of any reason to back up your statements that you made. Right, let's talk about the overlap in the middle 50%. Okay, so in this one, there are only 4 different types. So if you look at the first one, middle 50% is a box, right? There is no overlap in the boxes spread off the middle 50%. So we know that B is shifted further up in the scale than A. So therefore we can say B tends to do better than A. So we can make the conclusion. Okay? If you have a look at the second one, yes, there is some overlap. However, look at the median. Is median A and B included in the overlap? No, none of the median is included in the overlap. So this means there's quite a bit of difference. So we can say B tends to do better than A. Okay? Right, next one. Yes, again, in A and B, there is big overlap. And this time, one of the median is included, contained in the overlap, which is B, right? B, median, is included in the overlap. So, however, we can still say B tends to do better than A. Okay, then what's the difference? The last one. Yes, significant amount of the box middle 50% is overlapping, and also both medians are contained with the overlap. So that means that those two values are too similar. So if I do it again, if I, for example, this is a algebra test for year 11 students, say this is the case, if they redo the test, they will still get similar results. Okay, so this you can say there is insufficient evidence to judge if B tends to be better than A. Right, this one does not have overlap in the middle 50%, right? Okay, then you have to talk about percentage. 75% of the boys' scores are below 75% of girls. What does that mean? Okay, so this is 25, 25, 25. This is 75%. Since the box is not overlapping, 75% of boys' test score are below the 70. We have to go opposite side, starting from this end, 25, 25, 25, which is 75%. So comparing, 75% of boys' test score are below the 75% of year 10 girls' math score. Okay? So you can conclude that since there is a significant difference, girls are better than boys. We can conclude with an answer. Okay, let's have a look at this one. Does this one has overlap? Of course, this much, right? Median, one of the median is inside it. So can we still conclude one's better than the other? Yes. Okay, let's have a look. Alright, so there is overlap in the spread of middle 50%, and only the boys one is included in the overlap. That's what I've said over here. Okay, so now I need to include the data. 50% of year 10 boys had the math test that were lower than the 75%. So let's have a look where these values come from. Right, 50% of boys, which is coming from this way, 25, 25, which is 50%, is lower than coming from the other side, 25, 25, 25, which is 75, okay? Lower than 75% of the girls' score. You get that? Right, but we can still conclude that girls tends to be higher than the boys one. This means if they do it again, do the same test again, or similar test again, they will still get the similar result, which is girls still be better than boys. Okay, let's have a look at this one. Does it have overlap? Yes, of course. I'm looking at the upper quartile of the boys and lower quartile of the girls, and both medians are both contained inside the overlap. So, you need to explain it like this in context. And what do you need to do? Obviously, conclude that it has insufficient evidence to judge because the values are too similar, right? since the medians, both medians, lies within the overlap. So if we redo the test, similar test again, next time boys might be better than girls because the value of the two were too similar. Okay, so let's do this true and false question. Calculation for interquartile range is upper quartile minus lower quartile. What is it? Obviously, yes, that's correct. Range is minimum minus maximum. Is this correct? No, it's maximum minus minimum. You will get like negative value if you do the other way. Right, the spread of the middle 50% of the boys' test score is wider than girls' test. Yep, so I'm looking at the middle 50%, the box. Which one's wider? Is this correct? No. Okay, girls are wider than boys. What does it mean? Okay, if girls 50%, middle 50% is wider, that means they have more variation in the test score. Okay, some girls do really well, some girls don't do really well. Okay, so there's some variations in test. Whereas boys one, their scores are quite clustered. Okay, last one. Is it true or false? This one is true. Well done. Okay, let's have a look at this one. Right, the first one. Is this true? No. There is a significant difference between girls and boys' math test. No, because we have a significant amount of overlap and both medians lies within the overlap, right? So it's false. Next one, medians of the test result for boys and the girls are contained in the overlap. Yep, this is true. And therefore, there is insufficient evidence to judge. Is that right? That's right, because both medians included in the overlap. So therefore, if you redo the test next time, since it's too close, boys might be better next time. So we cannot say which one's better. Okay, last one. Let's have a go. Right, is the first one true, false? Nah, it's false. So median, yes, there's a huge amount of median, but only one, which is girls, are contained in the overlap. Okay, next one. 50% of Year 10 boys had math test score that were lower than 75% of math test score. Is this correct? So 50% of boys, yes, they are lower than 75. I'm counting from the top upper quartile to the lower quartile. 75%, yep, for girls. Okay, so therefore I cannot tell if there is a significant difference of boys and girls. Is this true? No, we can still say girls tends to receive better marks than boys. Okay, because not both medians lie contained in the overlap. There was only one. Okay, so you can make a call. Right, so we just finished the overlap sections. We only have 2 more to go. Okay, so comparing the middle 50%. This one, we're comparing the width of the middle 50%. Okay, so let's have a look. From our sample, I noticed that which group? Yeah, females interquartile range. For what's the variable here? What are we measuring? Back weight. Is it wider? Narrower? What is it? It's slightly smaller. Yeah, the box is slightly smaller than the interquartile range of, what's the other group? Males. Okay, so that was easy. So the first statement that you have to say in the middle 50% is which box is wider or smaller than the other. That's what you need to say. Okay, then once you said that, okay, you need to include some values. to back up. Okay, so calculate the interquartile range for female and calculate the interquartile range for male and compare them. Okay, so here I calculate for female one, which is 3,000, whereas male's one, 3,400. So it's a difference of 400 grams, okay? That's good to write it down, it's not there. Right, this means that the middle 50% is wider for male than female. Okay. Right, give me some insight. What does that mean? That means wider middle 50% means the value of middle 50% are more spread out. So therefore, boys' back's weight are slightly more variable than the girls. Okay, and give me some examples like what I've said, that the girls bringing hairbrush and so on, that one I said in the previous question. Yep, so think of some reasons and write it down. Okay, so this is another example for you to have a look at. Okay, have a look at it and see whether you can answer similarly. Right, therefore we just finished comparing the middle 50%. Okay, the last one, interesting feature. Right, this really depends on your box and whiskers, the data that you will have in front of you. However, you can talk about outliers if there is, but it needs to be very obvious, remember. Other one is clusters. You can talk about clusters as well if you have some in your data. Okay, or comparing center or upper quartile if they're the same, or if the max is same with the minimum or the minimum of the other, that's going to be another interesting thing to look at. So compare. Okay, so something about that, anything that catches your eyes. Okay, so there you go. This is how you need to talk about what you need to compare when you are comparing box and whiskers. Okay, so remember these 5 things. So these 5 points is where you will get the points from.